Picture yourself standing at the edge of everything, where the stars fade and the universe itself seems to whisper, "What's next?" Beyond the galaxies, beyond the light, lies a mystery that pulls at the heart of every dreamer. What's out there, past the boundaries of all we know? This is no ordinary journey. It's a leap into the unknown, a quest to uncover what lies outside the universe. From the spark of creation to the vast cosmic web, this story will unravel the enigma of existence itself, daring you to imagine a reality with no end or an edge that changes everything. Let's dive into the greatest question of all. What is the universe, and what could possibly lie beyond its limits? The universe is a word we toss around easily, but its meaning is almost too big to hold. It's the sum of all things. Every galaxy spinning in the dark, every star burning with fire older than Earth, every particle buzzing in the air around you. It's the planets orbiting distant suns, the comets streaking through space, the black holes that swallow light itself. It's the coffee in your cup, the thoughts in your mind, the gravity that keeps your feet on the ground. When we say universe, we mean everything that exists, from the tiniest speck of matter to the vast cosmic web of galaxies stretching billions of light years across. But here's the tricky part. When we try to imagine the universe, we often picture it as a giant container, like a box holding all these wonders. We can't help but ask, what's outside the box? Is there a wall, a void, or something else entirely? To answer that, we need to understand what the universe is made of and how it behaves, because the clues to its edges lie in its very nature. Let's start with the stuff of the universe. At its core, the universe is made of matter and energy. Matter is the tangible stuff, atoms that form stars, planets, and even you. Energy is what makes things move, shine, or explode, from the light of a distant star to the heat of a supernova. Matter and energy are deeply connected, transforming into each other in ways that power the cosmos. This dance of matter and energy fills the universe with everything from glowing nebulae to the invisible pull of gravity. But the universe isn't just a collection of things. It's also the space they exist in and the time they move through. Space and time aren't just a backdrop, they're part of the universe itself, woven together into a flexible fabric that bends and curves around stars and planets, shaping how everything moves. This fabric isn't something you can step outside of. It's part of the universe's essence. So when we ask what's outside the universe, we're not just asking about a place beyond the stars, we're asking about the edges of space and time themselves. To make sense of this, let's try a simple analogy. Imagine the universe as the surface of a balloon. The surface is all there is. No inside, no outside, just the rubbery sheet. Every point on that surface represents a place in the universe. Every star, every galaxy. As you blow air into the balloon, it expands, and all the points move farther apart. That's like the universe growing, which we know it's doing because scientists have observed galaxies drifting away from each other. But here's the catch. If you're an ant crawling on that balloon's surface, you can't find an edge. You can walk forever, and you'll never fall off or hit a wall. The surface just curves back on itself. This is one way scientists think about the universe. It might not have an edge at all. It could be finite, like the balloon's surface, but still boundless, meaning you'd never find a place where the universe stops. But if there's no edge, what does that mean for outside? Is there another balloon out there, or just nothing? This is where our minds start to stretch, trying to picture something beyond the only reality we know. Let's take a step back and think about what an edge would even mean. If the universe has a boundary, like the wall of a room, what's on the other side? Another room. A void? Something we can't even imagine. The idea of a boundary feels natural because we're used to things having limits. A forest ends at a meadow, a city ends at a desert, an ocean ends at a shore. But the universe isn't like a forest or an ocean. It's the thing that holds all forests, oceans, and everything else. If it has an edge, it's not like a wall you could touch or a line you could cross. Some scientists suggest that if you traveled far enough, You might loop back to where you started, like circling the Earth. Others say the universe could be infinite, stretching forever without any boundary at all. Both ideas are dizzying, and neither gives us a clear picture of what outside could be. To explore this, we need to dig into how the universe began, because its origin might hold clues to its edges. The story of the universe's beginning is one of the most incredible tales science has ever told. About 13.8 billion years ago, everything we know, every star, every planet, every speck of light, started with a single event called the Big Bang. Picture an explosion, but not like a bomb going off in a room. This explosion wasn't in space. It was the creation of space itself. It wasn't in time. It was the start of time. Before the Big Bang, there wasn't just nothing. There was no before. It's a concept that's hard to wrap your head around, because we're used to thinking of time as a line that goes backward and forward forever. But in the moments after the Big Bang, the universe was a tiny, hot, dense point, smaller than an atom, filled with energy. That point expanded rapidly, cooling as it grew, forming the first particles, then atoms, then stars and galaxies. This expansion is still happening today, like that balloon we imagined, stretching bigger every second. The Big Bang gives us a starting point for the universe, but it doesn't tell us if it has an edge or what might lie beyond. If the universe started as a single point, you might wonder, where was that point? Was it floating in some bigger space? The answer is no. At least not in the way we think of space. That tiny point was the universe, and it contained all of space and time. There was no outside for it to exist in. This is where our everyday intuition fails us. We're used to picturing things happening somewhere, but the Big Bang didn't happen in a place. It created all places. So when we ask what's outside the universe, we're trying to apply the idea of place to something that might not follow those rules. It's like asking what's north of the North Pole. There's no north beyond it, because the North Pole is the farthest point in that direction. The universe might be similar. There might not be an outside because it's all there is. But let's push further. Even if the universe is all there is, could there be something else? Something separate from it? To explore this, we need to think about what outside means. In our daily lives, outside is simple. Step outside your house, and you're in the yard. Fly outside Earth, and you're in space. But when it comes to the universe, outside isn't a place you can travel to. It's not like you could build a spaceship, fly to the edge, and peek over a cosmic fence. Space itself is part of the universe, so there's no space to travel through to get outside. Time is part of the universe too, so there's no moment when you could exist beyond it. This makes the question both frustrating and fascinating. It's like trying to imagine a color you've never seen, or a sound you've never heard. Our brains are built to understand things within the universe, so picturing something outside it feels like chasing a shadow. Let's try another analogy to make this clearer. Imagine you're playing a video game, one of those open world games where you can explore a huge map. You run through forests, climb mountains, sail across seas, but eventually you hit the edge of the map. Maybe the game stops you with an invisible wall, or maybe it loops you back to the other side. The game's world is all you can explore. There's no outside the map, because the game's code doesn't exist beyond it. The universe might be like that. It could be a self-contained system with no outside because there's no code, no reality beyond its boundaries. But here's where it gets wild. What if our universe is just one game running on a cosmic computer? Could there be other games, other universes running alongside ours? This idea hints at something called the multiverse, which we'll explore later in the documentary. But for now, it's enough to make us wonder if our universe is the only one. To understand the universe's edges, we need to look at how it behaves today. Scientists have spent decades studying the cosmos, using telescopes to peer at distant galaxies and satellites to measure the faint glow left over from the Big Bang. One thing they've learned is that the universe is expanding. Galaxies are moving farther apart, not because they're flying through space, but because space itself is stretching, like dough rising in an oven. This expansion is a clue to the universe's shape. If the universe is finite, like the surface of that balloon, it might curve in a way that makes it boundless. No edges, no walls. If it's infinite, it goes on forever, and the idea of an edge doesn't even apply. Scientists measure this by looking at how light travels and how gravity shapes the cosmos. So far, the evidence suggests the universe is flat, like an endless sheet, but it's not certain. A flat universe could still be infinite, or it could have some strange shape we haven't figured out yet. Let's pause and think about what infinite really means. If the universe is infinite, it doesn't just go on for a long way. It goes on forever. No matter how far you travel, you'd never reach an end. Picture a road that never stops. No matter how fast you drive or how long you go. It's hard to grasp because everything in our lives has limits. Even the biggest things we know, oceans, mountains, the earth itself have boundaries. An infinite universe challenges that, but a finite universe is just as strange. If it has a boundary, what's it like? Is it a wall you could touch, a shimmering barrier, or something so alien we can't even describe it? And if there's a boundary, what's beyond it? Nothingness? Another universe? Something that doesn't follow the rules of space and time? These questions pull us into a cosmic riddle, one that science is still trying to solve. One way scientists try to answer these questions is by studying the universe's structure. They've mapped out galaxies, clusters, and superclusters, giant groups of stars and gas held together by gravity. These form a cosmic web with filaments of galaxies stretching across vast voids of empty space. But even this web doesn't tell us if there's an edge. The farther we look, the more galaxies we see, and our telescopes can only see so far. There's a limit to what we can observe, not because of a wall, but because light takes time to travel. The universe is 13.8 billion years old, so the light from the furthest objects has taken that long to reach us. Beyond that, there's a cosmic horizon, a point where light hasn't had time to get here yet. Does that horizon mark the edge of the universe? No, it's just the edge of what we can see. The universe could extend far beyond, maybe forever. This cosmic horizon is a bit like standing on a ship in the middle of the ocean. You can only see so far before the horizon, but the ocean goes on. The universe might be like that ocean, stretching beyond what we can see, with no clear boundary. But unlike an ocean, the universe includes space and time, so the idea of beyond gets murky. Some scientists think the universe might loop back on itself, like a sphere or a more complex shape called a torus, which looks like a donut. In such a universe, you could travel in a straight line and end up back where you started, with no edge at all. Others think it might be infinite, with no boundaries to find. Both possibilities challenge our sense of reality, making the question of outside even harder to answer. Let's explore the idea of nothingness for a moment, because it's one possible answer to what's outside the universe. When we say nothing, we often picture an empty room or a dark void, but true nothingness is stranger than that. It's not just empty space, it's the absence of space, time, matter, and energy. It's not even black or silent, because blackness and silence are still something. True nothingness is the complete lack of existence. Try to imagine that. Your mind probably rebels, conjuring up images of darkness. Nothing looks like a black screen, but that's still a picture, a place. Nothingness isn't a place, it's not even a thing. If the universe has an edge, and nothingness lies beyond, it wouldn't be like stepping into a void. It would be the end of stepping, the end of being. This idea is so alien, it feels like a paradox, and it's one reason why the question of outside is so hard to grasp. But what if there's something instead of nothing? What if the universe is just one part of a larger reality? This is where things get wild. Some scientists and philosophers have suggested that our universe might be one of many, like bubbles in a cosmic foam. Each bubble could be its own universe, with its own laws of physics, its own stars and galaxies. This is the multiverse idea we mentioned earlier, and while it sounds like science fiction, it's a serious theory in modern physics. The multiverse could exist outside our universe, but not in the way we think of outside. It's not a place you could travel to, it's a separate reality, disconnected from our own. The idea of multiple universes raises new questions. Are they infinite? Do they touch ours? Could we ever detect them? These questions push the boundaries of science and imagination, and they're a reminder of how little we know about the true nature of reality. To bring this back to Earth, let's think about how we humans have tried to understand the universe's edges for centuries. Ancient people looked at the stars and imagined a dome of sky, a solid ceiling holding the heavens. Beyond it, they pictured gods, spirits, or sacred realms. As science grew, we replaced those myths with telescopes and equations. But the core question remained: where does it all end? Philosophers like Immanuel Kant argued that the universe could be infinite in theory, but our minds struggle to comprehend it. Scientists showed that space and time are flexible, bending under the weight of matter and energy. Today, we use giant telescopes and particle accelerators to probe the universe's secrets, but the edge, if it exists, remains out of reach. The more we learn, the more we realize how much we don't know. Let's try one more analogy to wrap our minds around this. Picture the universe as a book. Every page is a galaxy, every word a star, every letter an atom. The book is the universe, all of space, time, matter, and energy. If the book is finite, it has a last page. But what's beyond that page? Is it just the table the book sits on, or is there another book? If the book is infinite, the pages go on forever, and there's no outside to find. But even an infinite book might sit on a table, in a room, in a world of other books. The question of what's outside the universe is like asking what's outside the book of everything. Is there a table, a room, a library, or is the book all there is? Science doesn't have a final answer, but it keeps turning the pages, looking for clues. As we end this first chapter, we're left with a sense of awe and curiosity. The universe is everything we know, every star, every planet, every moment. It might be finite, curving back on itself like a balloon's surface, or infinite, stretching forever. It might have an edge we can't imagine, or no edge at all. Beyond it, there could be nothingness, a void beyond comprehension, or other universes, each with its own story. The question of what lies outside the universe isn't just about space, it's about the limits of reality itself. As we move forward in this documentary, we'll dive deeper, exploring the cosmic horizon, the multiverse, and the philosophical frontiers that challenge our understanding. For now, let's hold on to that feeling of standing at the edge of everything, staring into the unknown, wondering what mysteries await. Let's start with something simple. The universe is huge, like really huge. If you tried to count every star in every galaxy, you'd run out of numbers before you got close. Scientists estimate there are about 2 trillion galaxies in the observable universe, each one stuffed with billions of stars. That's a lot of twinkling lights. But here's the kicker. The observable universe is only the part we can see. It's like standing in the middle of a giant foggy field where you can only make out the trees and hills within a certain distance. Beyond that, the fog swallows everything. In the universe, that fog isn't mist, it's light, or rather, the lack of light reaching us from places too far away. So, what's this cosmic horizon we keep talking about? Picture this. When you look up at the night sky, you're not just seeing stars, you're seeing the past. Light from those stars takes time to travel to your eyes. The farther away something is, the longer it takes for its light to reach us. The sun's light takes about 8 minutes to get to Earth. So when you look at the sun, don't do that, by the way. You're seeing it as it was 8 minutes ago. Now, stretch that idea out. The light from distant galaxies might have been traveling for billions of years. When we look at those galaxies through powerful telescopes, we're peering back in time, seeing them as they were when the universe was young, maybe even just a baby. But there's a limit to how far back we can look. The universe, as far as we know, kicked off about 13.8 billion years ago with the Big Bang, a colossal explosion of energy that set everything in motion. You'd think then that the furthest we can see is 13.8 billion light years away, right? After all, a light year is the distance light travels in a year, so light from something farther than that wouldn't have had time to reach us since the universe began. But here's where things get wild. The universe is expanding. It's not just sitting still like a calm lake. It's more like a balloon that's constantly inflating. As space itself stretches, the distances between galaxies grow, and that messes with our simple math. Because of this expansion, the observable universe is actually much bigger than 13.8 billion light-years across. Scientists estimate it's about 93 billion light-years in diameter. That's the size of the bubble we can see, the part of the universe where light has had enough time to reach us. But beyond that, that's the cosmic horizon, the edge of our vision, like the line where the ocean meets the sky. Anything past that horizon is too far away for its light to have reached us yet. Even if it's been traveling since the Big Bang, it's like trying to see a ship that's sailed so far over the horizon that its light hasn't had time to catch up with you. Now, let's pause for a second and let that sink in. The observable universe is everything we can see, everything we can know about with our telescopes and our science. It's a bubble of space filled with galaxies, stars, planets, and maybe even alien worlds we can only dream of. But that bubble has an edge, and beyond that edge, we're blind. So what's out there? Is it just more of the same? More galaxies, more stars, more cosmic wonders? Or is it something completely different? Something our minds can barely grasp? To answer that, we need to dig a little deeper into how the universe works and why this horizon exists in the first place. The cosmic horizon exists because light has a speed limit. That's one of the fundamental rules of the universe, discovered by Albert Einstein. Light travels at about 106,000 miles per second, 300,000 kilometers per second, which sounds insanely fast, but in the grand scheme of the cosmos, it's practically a crawl. The universe is so vast that even light takes billions of years to cross it. And because the universe is expanding, the space between us and those faraway places is stretching faster than light can travel. Imagine you're on one end of a rubber band, and someone on the other end is running away from you while the rubber band keeps getting longer. Even if you send a message at the speed of light, it might never reach them because the distance is growing too fast. That's what's happening with the farthest parts of the universe. This expansion is why the cosmic horizon is such a tease. There could be galaxies, stars, and entire cosmic stories unfolding out there. But their light will never reach us because the space between us is stretching too quickly. It's like the universe is playing a cosmic game of keep away, hiding its secrets just out of reach. Scientists call this the cosmological horizon, or sometimes the light horizon. It's not a physical wall or a barrier you could touch. It's just the limit of what light can show us. And that limit is moving farther away all the time as the universe keeps expanding. But here's where things get really interesting. Just because we can't see beyond the horizon doesn't mean there's nothing there. The universe doesn't just stop at the edge of our vision. In fact, most cosmologists believe the universe goes on far beyond what we can see, maybe even forever. The observable universe is just a tiny piece of a much bigger puzzle. To understand what might be out there, we need to think about what the universe is made of and how it behaves. Is it the same everywhere? Or does it change as you get farther and farther from our little cosmic neighborhood? Let's start with the idea that the universe might be infinite. That's a big word, infinite, and it's hard to wrap your head around. If the universe is infinite, it means it goes on forever, with no end, no edge, no boundary. Picture an ocean that never stops, no matter how far you sail. In an infinite universe, there could be more galaxies, more stars, more planets stretching out forever. Maybe there's another Earth out there, with another you reading this very script. Hi, other you. The idea of an infinite universe is mind-blowing, because it suggests that everything that could happen does happen somewhere in some corner of this endless cosmos. But infinity is tricky. It's not just really big, it's a concept that breaks our brains a little. If the universe is infinite, what's outside it? Does outside even make sense? Some scientists argue that if the universe is infinite, there's no such thing as an outside, because the universe is all there is. It's like asking what's north of the North Pole. There's nowhere left to go. But other scientists aren't so sure. They think the universe might be finite, like a giant sphere or a weird curved shape that loops back on itself. If that's true, then maybe there's something beyond it, a cosmic outside that's different from the universe we know. Let's explore that finite universe idea for a moment. Imagine the universe as a giant balloon. The surface of the balloon is all of space. Every galaxy, every star, every planet exists on that surface. If you travel far enough in one direction, you might end up back where you started, like circling the Earth. This kind of universe doesn't have an edge, but it's still finite. It has a certain amount of space. Now, if the universe is like that, what's outside the balloon? Is it just empty space, a vast nothingness? Or is it something else entirely, like a different kind of reality? This is where we start to venture into the realm of speculation. Because science doesn't have a telescope powerful enough to peer beyond the cosmic horizon. But that doesn't mean we can't imagine or theorize. One idea is that our universe is just one bubble in a much bigger cosmic foam. Each bubble could be its own universe, with its own stars, galaxies, and laws of physics. This is called the multiverse theory, and we'll dive deeper into it in the next chapter. But for now, think of it like this. Our observable universe is one room in a giant cosmic house, and beyond our walls, there might be other rooms with their own rules, their own stories. But let's not get too far ahead of ourselves. Let's stick with the cosmic horizon and what it means for what's out there. If our universe is finite, there could be a boundary, a kind of edge where our universe stops. But what would that edge look like? It's not like a brick wall or a "you are now leaving the universe" sign. Some physicists think a finite universe might just curve in on itself, so there's no edge at all. Others imagine a boundary where space and time as we know them stop making sense. Beyond that, you might find a void, a place with no matter, no light, no nothing. Or maybe it's not a void at all. Maybe it's a place where the rules of physics are different, where gravity doesn't work the way it does here, or where time flows backward. Let's try a different analogy to make this clearer. Picture the universe as a giant, glowing snow globe. Inside the globe, you've got all the stars and galaxies swirling around in a beautiful dance. The edge of the snow globe is the cosmic horizon, the farthest light can travel to reach us. Now, what's outside the snow globe? Is it just the table it's sitting on, a boring, empty void? Or is it a whole room full of other snow globes, each one a different universe with its own cosmic dance? Or maybe the snow globe is floating in some kind of cosmic soup, a weird, unimaginable place where the rules of our universe don't apply. This idea of a void sounds spooky, doesn't it? When we say nothing, we often picture darkness, emptiness, like a blank canvas. But in physics, nothing isn't always what it seems. Even in the emptiest parts of space, there's something going on. Scientists talk about quantum fields, invisible energy fields that fill the universe and give rise to particles like electrons and quarks. Even in a vacuum, these fields are buzzing with tiny fluctuations, like static on a TV screen. So if there's a void beyond our universe, it might not be empty at all. It could be a seething, bubbling sea of energy, waiting to spark new universes or new kinds of reality. Let's take a step back and think about why this matters. Why do we care what's beyond the cosmic horizon? For one thing, it's just human nature to wonder. We've always looked at the edges of our maps and asked, what's out there? Whether it was explorers sailing across oceans or astronauts landing on the moon, we're driven by the need to know. The cosmic horizon is the ultimate edge, the farthest frontier we can imagine. And even if we can't see past it, thinking about it pushes us to ask big questions. What is the universe? Where did it come from? Are we alone, or are we just one tiny piece of something much bigger? To explore these questions, scientists use tools like telescopes, particle accelerators, and math, lots of math. Telescopes like the Hubble Space Telescope and the James Webb Space Telescope let us peer closer to the cosmic horizon than ever before. They show us galaxies so far away that their light has been traveling for almost the entire history of the universe. When we look at those galaxies, we're seeing the universe when it was young, just a few 100 million years old. That's like looking at a baby picture of the cosmos. But even these incredible machines can't see past the horizon. The light from beyond is still too far away, stretched out of reach by the expanding universe. So we turn to math and theory to fill in the gaps. One of the coolest ideas in cosmology is called cosmic inflation. It says that right after the Big Bang, the universe went through a super fast growth spurt, expanding faster than the speed of light. Don't worry, that doesn't break Einstein's rules. Space itself can expand faster than light, even if nothing in it can. This inflation stretched the universe so much that parts of it zoomed out of sight, far beyond our cosmic horizon. Those parts might still be out there, filled with galaxies and stars we'll never see. Or they might be completely different, with physics we can't even imagine. Another idea is that the universe is flat. Not flat like a pancake, but flat in a mathematical sense. Imagine a giant sheet of paper that stretches out forever. If the universe is flat and infinite, then beyond our cosmic horizon, it's probably more of the same. Galaxies, stars, planets, maybe even life. But if the universe is curved, like a sphere or a saddle, things get weirder. A curved universe might loop back on itself, or it might connect to something else entirely. These are the kinds of ideas that keep cosmologists up at night, scribbling equations and dreaming of the unknown. Let's try one more analogy to bring this home. Think of the universe as a giant library, and the observable universe is one bookshelf. That bookshelf is packed with incredible stories, galaxies, black holes, supernovas, maybe even planets with life. But the library is so big that you can't see the other bookshelves. Are they filled with the same kinds of stories, or are they totally different? Maybe some shelves have books written in languages we can't read, with physics we can't understand. Or maybe the library itself is sitting in a bigger building, and that building is part of an even bigger city. That's what we're trying to figure out when we ask what's beyond the cosmic horizon. As we wrap up this chapter, let's think about what it means to stand at the edge of the observable universe. We're like explorers on that ship, staring out at the cosmic ocean, wondering what lies beyond the horizon. We can't see it, but we can imagine it. Maybe it's more galaxies stretching out forever. Maybe it's a void buzzing with quantum energy. Maybe it's other universes, each one a different snow globe in a cosmic collection. Or maybe it's something so strange we don't even have the words to describe it yet. What's clear is that the cosmic horizon isn't just a limit, it's an invitation. It's a challenge to keep asking questions, to keep building better telescopes, to keep dreaming up new theories. The universe is full of mysteries, and the biggest ones lie just out of sight, waiting for us to find a way to peek past the curtain. In the next chapter, we'll take a leap into one of the wildest ideas of all, the multiverse, where our universe might be just one of many. But for now, let's linger at the horizon, marveling at how much we've learned and how much more there is to discover. This chapter has taken us to the edge of what we can see, but the journey doesn't stop here. The universe is vast, and our curiosity is even bigger. So let's keep sailing, keep exploring, and keep asking, what's out there beyond the cosmic horizon? At the end of our last chapter, we stood at the edge of the cosmic horizon, gazing out at the farthest reaches of our observable universe. It was like standing on the deck of a ship, staring at a shimmering line where the cosmic ocean meets the sky, wondering what lies beyond. We learned that the universe is vast, maybe even infinite, and that the light from beyond that horizon might never reach us, stretched out of sight by the universe's relentless expansion. But here's where our journey takes a thrilling turn. What if our universe, with its billions of galaxies, stars and planets, is just one piece of a much bigger puzzle? What if it's just one room in a cosmic mansion, with countless other rooms, each holding its own version of reality? Welcome to Chapter 3, where we fling open the door to the wild, mind-bending idea of the multiverse, a place where parallel worlds might exist, each singing its own cosmic song. Let's rewind for a moment to get our bearings. In Chapter 2, we talked about the observable universe, our bubble of space, about 93 billion light-years across, filled with everything we can see or hope to see with our telescopes. We learned that the cosmic horizon marks the limit of our vision, not because there's a wall out there, but because light from farther away hasn't had time to reach us, and the universe's expansion is pulling those distant places farther away every second. But we also hinted at something bigger, the idea that our universe might not be the whole story. Beyond the horizon, there could be more of the same, more galaxies, more stars, or there could be something entirely different. That's where the multiverse comes in, and it's a concept that's as exciting as it is brain-twisting. So, what exactly is the multiverse? In simple terms, it's the idea that our universe isn't alone. It's not the only game in town. Instead, it's one of many universes, each with its own set of rules, its own physics, its own story. Think of it like a cosmic apartment building. Our universe is one apartment, furnished with galaxies, stars, and the laws of physics we know, like gravity, electromagnetism, and the speed of light. But next door, there might be another apartment, another universe, where gravity works differently, or where time flows backward, or where stars burn in colors we can't even imagine. These other universes might be completely separate from ours, with no way to visit or even peek inside, but their existence could explain some of the biggest mysteries about our own cosmic home. To make this idea a little less dizzying, let's use an analogy. Imagine the multiverse as a giant foam of bubbles, like the froth on top of a soda. Each bubble is a universe, floating in a vast cosmic sea. Our universe is one bubble, with its own unique sparkle. Our galaxies, our laws of physics, our Earth. But there are other bubbles out there, each one a different universe. Some might look a lot like ours, with stars and planets. Others might be so strange that they defy imagination, with dimensions we can't picture, or physical laws that break all our rules. This bubble universe idea is one of the most popular versions of the multiverse theory, and it's a great place to start our journey into this cosmic wonderland. But why do scientists even think there might be a multiverse? After all, we can't see beyond our cosmic horizon, so how can we possibly know if other universes exist? The answer lies in a mix of science, math, and a healthy dose of imagination. Let's go back to the Big Bang, the moment our universe was born about 13.8 billion years ago. We mentioned in Chapter 2 that right after the Big Bang, the universe went through a super fast growth spurt called cosmic inflation. It was like the universe hit the gas pedal, expanding faster than the speed of light for a tiny fraction of a second. This inflation stretched space so much that parts of it zoomed out of sight, far beyond our cosmic horizon. Here's where things get interesting. Some scientists believe that cosmic inflation didn't just happen once, in one place, to create our universe. Instead, they think inflation might be happening all the time, in different parts of a much bigger cosmic landscape. Each time inflation kicks in, it creates a new bubble, a new universe. This is called the eternal inflation theory, and it's one of the main ideas behind the multiverse. Picture a cosmic popcorn machine, popping out new universes every time a kernel of inflation goes off. Our universe is one of those kernels, popped into existence by a burst of inflation, but there are countless others out there, each one a separate bubble in the cosmic foam. Let's dive deeper into this bubble universe idea, because it's both mind-blowing and surprisingly easy to picture. Imagine you're blowing bubbles through a wand, like you did as a kid. Each bubble floats off, shimmering and complete, but no two bubbles are exactly the same. Some are big, some are small, some pop quickly, others drift for a while. In the multiverse, each bubble is a universe, created by its own burst of inflation. Inside each bubble, the laws of physics settle into place, but they might settle differently in each one. In our universe, the laws of physics are just right for stars to shine, planets to form, and life to exist. But in another bubble, gravity might be too weak to hold stars together, or the speed of light might be different, creating a universe that looks nothing like ours. This idea of different laws of physics is what makes the multiverse so exciting. In our universe, everything works the way it does because of a few key numbers, called physical constants. For example, there's the strength of gravity, the mass of an electron, or the way electromagnetic forces hold atoms together. These numbers are finely tuned, almost like the settings on a cosmic dial. If you tweak them even a little, our universe wouldn't work the same way. Stars might not form, or atoms might fall apart. Scientists call this the fine-tuning problem. Why are these numbers just right for life to exist? One answer is the multiverse. Maybe there are countless universes, each with its own settings, and we just happen to live in one where the dials are set perfectly for us. To make this clearer, let's use another analogy. Think of the multiverse as a giant cosmic radio, with each universe tuned to a different station. Our universe is playing a song we love, call it the Galaxy Waltz, with stars, planets, and life dancing along. But other universes might be playing heavy metal, jazz, or static noise, completely different tunes with different rules. In some universes, the laws of physics might allow for exotic forms of matter, like particles that move faster than light. In others, there might be no matter at all, just pure energy or strange fluid-like space. The multiverse theory suggests that every possible combination of physical laws exists somewhere, in some other bubble. But how do we even start to imagine these other universes? One way is through a scientific idea called string theory, which is like a cosmic recipe book for building universes. String theory says that everything in our universe, every particle, every force, is made of tiny vibrating strings of energy. These strings are so small that we'll never see them, but their vibrations determine how the universe works. It's like the strings on a guitar. Depending on how they're plucked, you get different notes, different songs. In string theory, the notes are the particles and forces that make up our universe. Here's the wild part. String theory predicts that there are many possible ways to tune these strings, creating different universes with different physics. Some versions of string theory suggest there could be 10,500 possible universes. That's a 1 followed by 500 zeros. That's more universes than there are grains of sand on every beach on Earth. Each one could have its own unique combination of forces, particles, and dimensions. Some might have 3 dimensions of space like ours. Others might have 4, 5, or even 10 dimensions, creating realities we can't even picture. Let's pause for a second to let that sink in. The multiverse isn't just about other places. It's about other kinds of places. Imagine a universe filled with vibrant imagery. This chapter paints a vivid picture of these bizarre, unimaginable realities. A universe with 2-dimensional space, where everything is flat like a piece of paper. A universe where gravity is so strong that stars collapse into black holes instantly. A universe with extra dimensions curled up so tiny we can't see them, but they change how everything works. These parallel worlds aren't just far away. They're fundamentally different, like dreams from another mind. But how do we know if these other universes are real? The truth is, we don't, not yet. The multiverse is still a hypothesis, a brilliant idea backed by math and theory, but not by direct evidence. We can't see beyond our cosmic horizon, so we can't peek into another bubble. But there are clues that keep scientists excited about the multiverse. For example, the cosmic microwave background, the faint glow of radiation left over from the Big Bang, has patterns that some scientists think could hint at collisions with other universes. It's like finding a dent in your bubble where another bubble bumped into it. These clues are far from proof, but they're enough to keep the idea alive and buzzing in the world of cosmology. Let's explore another version of the multiverse, one that's a bit easier to wrap your head around. This is called the many worlds interpretation, and it comes from quantum physics. Quantum physics is the science of the very small, atoms, electrons, and particles, even tinier than that. It's a weird world where things don't behave like they do in everyday life. For example, particles can exist in multiple states at once, like being in two places at the same time, until you look at them. The many worlds interpretation says that every time a quantum event happens, like an electron choosing one path or another, the universe splits into different versions, one for each outcome. Here's a simple way to picture it. Imagine you're at a fork in the road, trying to decide whether to go left or right. In the many worlds multiverse, the universe splits, and in one universe you go left, while in another you go right. Both versions of you exist, living different lives in parallel worlds. Now scale that up to every quantum event in the universe, every particle, every choice, and you get a mind-boggling number of parallel universes, branching off like an infinite tree. In one universe, you're watching this documentary. In another, you're an astronaut exploring a distant planet. It's a crazy idea, but it's one way to make sense of quantum physics' strangeness. This many worlds idea is different from the bubble universes of eternal inflation. Bubble universes are physically separate, floating in their own cosmic foam. Many worlds universes are more like overlapping realities, sharing the same space but existing in parallel. It's like having multiple radio stations broadcasting on the same frequency, but you can only tune into one at a time. Both ideas are part of the multiverse concept, and they both stretch our imagination to the limit. So what does it mean to live in a multiverse? For one thing, it makes our universe feel a little less special, but also a lot more mysterious. If there are countless other universes, then our cosmic home is just one of many, a single bubble in an infinite foam. But it also means the possibilities are endless. Somewhere out there might be a universe where dinosaurs never went extinct, or where gravity is so weak that people float like balloons. There might be a universe where you're the ruler of a galactic empire, or where the sky is green and the stars sing like whales. The multiverse is a playground for the imagination, where every what-if could be real somewhere. Let's bring this back to something more grounded. Why does the multiverse matter to us here in our own universe? For one, it could solve some of the biggest puzzles in science. Remember the fine-tuning problem we mentioned earlier? The idea that our universe's physical constants are perfectly set for life. The multiverse offers an answer. Maybe we're just lucky to live in a universe where the dials are set right. In other universes, the settings might be wrong, and life can't exist. It's like rolling a cosmic dice and getting the perfect number. Not because the dice are rigged, but because you rolled them a trillion times. The multiverse also challenges our sense of uniqueness. We like to think we're special, that our Earth, our universe, is the center of everything. But the multiverse says, maybe not. Maybe we're just one story in a cosmic library, one book on an infinite shelf. That's humbling, but it's also exciting. It means the universe, or the multiverse, is bigger, wilder, and more wonderful than we ever imagined. It's a reminder that our curiosity, our drive to explore, is what makes us human, even if we're just a tiny speck in the grand cosmic scheme. Of course, the multiverse isn't without its critics. Some scientists say it's not real science because we can't test it. If we can't see or touch another universe, how can we prove it exists? It's a fair point. The multiverse is a bit like a cosmic ghost story, beautiful, haunting, but hard to pin down. Other scientists argue that the math behind the multiverse, like string theory or eternal inflation, is so compelling that it's worth exploring, even without direct evidence. After all, we couldn't see black holes for a long time, but we believed in them because the math checked out. Maybe the multiverse is the same, a discovery waiting for the right tools, the right ideas. Let's imagine for a moment that we could visit another universe. What would it be like? Maybe you'd step into a world where the sky is a swirling rainbow of energy and the ground pulses with light. Maybe the laws of physics would feel like a dream, where you could walk through walls or fly without wings. Or maybe it would be so alien that your mind couldn't make sense of it. A place where up is down, time is a loop, and reality feels like a puzzle with no edges. The beauty of the multiverse is that it lets us dream these dreams, even if we can't prove them yet. As we wrap up this chapter, let's reflect on where we are in our cosmic journey. In Chapter 2, we stood at the cosmic horizon, wondering what lies beyond the light we can see. Now we've taken a leap into the multiverse, imagining a cosmic foam of universes, each with its own rules, its own story. The multiverse is a leap of faith, a blend of science and imagination that pushes the boundaries of what we think is possible. It's not just about other places, it's about other realities, other ways of being, other versions of everything. But our journey isn't over. The multiverse raises new questions, even bigger ones. If there are other universes, what's the space between them? Is it a void, a nothingness, or something even stranger? And what does it mean for us, living in our little bubble, to be part of something so vast? In the next chapter, we'll explore the idea of a cosmic void, or maybe something more beyond the boundaries of our universe. For now, let's linger in the multiverse, marveling at the idea that our universe might be just one note in a cosmic symphony, playing alongside countless others in a song we can only imagine. This chapter has taken us to places beyond our wildest dreams, parallel worlds, bubble universes, realities where the impossible is possible. But the universe, or the multiverse, doesn't stop surprising us. We've been on quite a cosmic journey so far, haven't we? In Chapter 2, we stood at the edge of the cosmic horizon, peering into the vastness of our observable universe, that shimmering bubble of space, 93 billion light-years across, where light from distant galaxies teases us with glimpses of the past. We learned that beyond this horizon lies a mystery, perhaps more galaxies, perhaps an infinite expanse, hidden by the stretching of space itself. Then, in Chapter 3, we flung open the door to the multiverse, imagining our universe as just one bubble in a cosmic foam, surrounded by countless other universes, each with its own rules, its own physics, its own story. Now, in Chapter 4, we're stepping even further into the unknown, asking a question that's both simple and profound. What's outside all of this? Is it a vast empty void, a cosmic nothingness, or is it something more? Something so strange we can barely dream it. Buckle up, because this chapter is about to take us to the very edge of imagination, where the universe as we know it fades away, and we're left wondering, is it the void or something more? Let's start by painting a picture. Imagine you're floating in space, far beyond the farthest galaxies, past the cosmic horizon where light can no longer reach us. You're drifting in a place where stars, planets, and even time itself seem to dissolve. What do you see? At first you might picture darkness, an endless, inky blackness, like the deepest part of the ocean where no light penetrates. This is what we often think of when we hear the word void, a place of absolute nothingness, a cosmic blank slate. But is that really what's out there, beyond our universe or the multiverse? Or is this nothing hiding something more, a structure, a reality, a mystery we haven't yet grasped? To find out, we need to explore what nothing really means in the context of the cosmos, and why the idea of a void might be far more fascinating than it sounds. When we talk about what's outside the universe, we're stepping into a realm where language itself starts to wobble. Words like outside or beyond assume there's a place, a space, a something to be outside of. But what if the universe, or the multiverse, is all there is? What if there's no outside at all, like asking what's north of the North Pole? In Chapter 2, we touched on the idea that the universe might be infinite, stretching on forever with no edge, no boundary. If that's true, then the question of what's outside doesn't make sense. There's just more universe, more space, more galaxies. But if the universe is finite, or if our bubble universe is just one of many in the multiverse, then the idea of an outside becomes tantalizingly real. And that's where we begin, with the possibility that there's a beyond, a place or non-place where our universe ends and something else begins. Let's start with the simplest idea, the void. When we say void, we're imagining a place with no matter, no light, no energy, just pure, absolute emptiness. It's the kind of emptiness that feels heavy, almost oppressive, like a silent room where even your thoughts echo too loudly. In everyday life, we rarely encounter true emptiness. Even the air around us is filled with molecules, and the empty space between stars is buzzing with tiny particles, radiation, and quantum fluctuations. But a cosmic void outside the universe would be different. It would be a place where the rules of our universe, space, time, gravity, light, might not apply at all. No atoms, no stars, no ticking clocks, just nothing. But here's where things get tricky. In modern physics, nothing isn't as simple as it sounds. Even in the emptiest parts of our universe, there's something going on. Scientists talk about quantum fields, invisible energy fields that fill all of space, like an ocean we can't see. These fields are never truly still. They're always vibrating, flickering with tiny bursts of energy that can pop particles into existence for a split second before they vanish again. It's like the universe is a giant stage, and even when the actors are gone, the stage is humming with potential, ready for the next performance. So if there's a void outside our universe, it might not be empty in the way we imagine. It could be a seething, bubbling sea of quantum energy, a place where the potential for new universes, new realities, is always simmering. To make this idea more vivid, let's use an analogy. Picture our universe as a glowing snow globe, like we did in Chapter 2. Inside, you've got stars, galaxies, and all the wonders of the cosmos, swirling in a beautiful dance. The edge of the snow globe is our cosmic horizon, the farthest we can see. Now imagine zooming out. What's outside the snow globe? At first you might think it's just the table it's sitting on, a flat, empty surface, a void. But what if that table isn't empty at all? What if it's covered in a shimmering, invisible mist, a kind of cosmic soup that's constantly bubbling, ready to form new snow globes, new universes? That's what some scientists think the void outside our universe might be like, a place that's not nothing, but a strange, dynamic something. This idea ties back to the multiverse we explored in Chapter 3. If our universe is one bubble in a cosmic foam, then the void might be the space between the bubbles. But what is that space? Is it a true void, with no properties at all? Or is it a kind of cosmic scaffolding, holding the multiverse together? Some theories suggest that this space is a higher dimensional realm, a place with more dimensions than the three of space and one of time we're used to. To understand this, let's try another analogy. Imagine you're a character in a two-dimensional comic book, living on a flat page. Your whole universe is that page length and width, but no height. If someone asked you what's outside your universe, you might point to the edges of the page, but you'd have no concept of up or down into the third dimension. Now what if our universe is like that comic book, and the void outside is a higher dimensional space we can't perceive? It's not empty, it's just beyond our ability to imagine. This higher dimensional idea comes from theories like string theory, which we touched on in Chapter 3. String theory suggests that the universe might have extra dimensions, maybe 7, 8 or more, curled up so tiny we can't see them. These dimensions aren't like the big open spaces we're used to. They're microscopic, wrapped up at scales smaller than an atom. But in the void outside our universe, those dimensions might unfold, creating a reality with more directions, more possibilities. It's like stepping out of a narrow hallway into a vast multi-dimensional cathedral, where the rules of up, down, left and right don't apply anymore. This kind of void isn't empty. It's a place where geometry itself becomes alien, a playground for realities we can't yet comprehend. Let's explore another possibility. What if the void isn't a void at all, but a structured something? In Chapter 3, we imagine the multiverse as a foam of bubble universes, each one created by a burst of cosmic inflation. But what holds those bubbles together? Some scientists propose that the space between universes is a kind of cosmic medium, a substrate that's neither matter nor energy as we know it, but something more fundamental. Think of it like the water in a fish tank, with each bubble universe floating inside. The water isn't part of the bubbles, but it's there, shaping their movement, connecting them. This medium might be the outside of our universe, a place where the laws of physics as we know them break down, giving way to something entirely new. To make this idea more concrete, let's dive into a specific theory called the bulk. In some versions of string theory, our universe is like a flat membrane, a brain, floating in a higher dimensional space called the bulk. The bulk isn't a void in the traditional sense. It's a realm with its own properties, its own physics. Other brains, other universes, might be floating in the same bulk, like sheets of paper stacked in a book. Sometimes these brains might even collide, sparking new big bangs, new universes. It's a wild idea, but it suggests that the void outside our universe could be a dynamic, structured place, filled with other brains, other realities, all interacting in ways we can't yet see. Let's try another analogy to bring this home. Imagine the multiverse as a giant cosmic orchestra, with each universe playing its own song. Our universe is playing a familiar tune, call it the Galaxy Symphony, with stars, planets, and gravity providing the melody. The void between universes might be the concert hall itself, the space where all these songs echo and overlap. It's not empty, it's alive with the vibrations of countless other performances, each one a different universe with its own rhythm. The bulk in this analogy is like the architecture of the concert hall, shaping how the music moves, how the universes interact. But what if the void isn't structured at all? What if it's truly nothing? Not even quantum fields, not even higher dimensions. This is the hardest idea to grasp, because our minds are built to think in terms of something, true nothingness. No space, no time, no laws of physics, is almost impossible to imagine. It's not darkness, because darkness implies light could exist. It's not silence, because silence implies sound could break it. It's a state where the very concepts of existence don't apply. Some philosophers and physicists argue that this kind of nothingness is logically impossible, because for there to be nothing, there has to be a something to define it. It's like trying to draw a blank page without the page itself. This brings us to a big question. Does outside the universe even make sense? If our universe contains all of space and time, then asking what's outside might be like asking what happened before the Big Bang. Time itself began with the Big Bang, so before doesn't exist in the way we think. Similarly, if space is defined by our universe, then outside might not exist either. But the multiverse changes the game. If our universe is one bubble in a cosmic foam, or one brain in a higher dimensional bulk, then the idea of an outside becomes meaningful again. The void, or whatever it is, could be the backdrop against which all universes exist, the canvas for the multiverse's masterpiece. Let's explore one more possibility. What if the void is a place where time and space behave differently? In our universe, time flows in one direction, from past to future, like a river carrying us along. But outside the universe, time might loop, twist, or even stand still. Imagine a place where cause and effect don't work the way we expect, where events happen in reverse or all at once. This kind of void wouldn't be empty. It would be a realm where our understanding of reality unravels. Scientists have speculated about such places in theories like quantum gravity, where space and time emerge from something more fundamental, like a cosmic code or a network of information. To picture this, think of our universe as a movie playing on a screen. The screen is space, and the frames are time, moving forward one by one. Outside the universe, the void might be the projector room, where the rules of the movie don't apply. There might be no screen, no frames, just a chaotic swirl of possibilities. Or maybe it's a place where multiple movies play at once, overlapping in ways that defy logic. This kind of void isn't nothing. It's a place where the very fabric of reality is different, woven from threads we can't yet see. Why does this matter to us here in our cozy little universe? For one, it pushes us to rethink what we mean by reality. If there's a void or something more outside our universe, it challenges our place in the cosmos. Are we the center of everything or just a tiny speck in a much bigger picture? The idea of a void or a structured beyond forces us to confront the limits of our knowledge, the edges of what we can imagine. It's humbling, but it's also thrilling. Every time we ask what's out there, we're stretching our minds, reaching for answers that might change how we see ourselves. Scientists are trying to tackle these questions with every tool they have. Telescopes like the James Webb Space Telescope let us peer closer to the cosmic horizon, but they can't see beyond it. Particle accelerators like the Large Hadron Collider probe the tiniest scales of reality, looking for clues about extra dimensions or quantum fields. And mathematicians scribble equations that hint at the structure of the multiverse or the nature of the bulk. But for now, the void, or whatever it is, remains a mystery, a blank space on the cosmic map that we're only beginning to explore. Let's reflect on where we are in our journey. In Chapter 2, we stood at the cosmic horizon, marveling at the limits of our vision. In Chapter 3, we leaped into the multiverse, imagining countless other universes with their own rules. Now in Chapter 4, we've ventured into the space beyond, wondering if it's a void, a higher dimensional bulk, or something even stranger. Each step has taken us further from the familiar, deeper into the unknown, and yet the more we explore, the more questions we find. What is the void made of? Is it truly nothing, or is it the seed of everything? And what does it mean to be part of a cosmos that might be just one piece of an infinite puzzle? As we close this chapter, let's linger on the edge of this mystery. The void, or something more, isn't just a scientific question, it's a human one. It's about our need to know, our drive to explore, our hunger for answers, whether it's a bubbling quantum sea, a higher dimensional cathedral, or a nothingness beyond imagining. The outside of our universe is a reminder that the cosmos is bigger than us, wilder than us, and more wonderful than we can ever fully grasp. In the next chapter, we'll bring this journey full circle, asking the ultimate question: why do we care? What does it mean to chase these cosmic mysteries? And what do they tell us about ourselves? For now, let's float in the void, or whatever it is, and dream of what lies beyond. We've traveled far on this cosmic journey, haven't we? In Chapter 2, we stood at the edge of the cosmic horizon, gazing into the shimmering bubble of our observable universe, a 93 billion light-year expanse of stars, galaxies, and mysteries, wondering what lies beyond where light can reach. In Chapter 3, we flung open the door to the multiverse, imagining our universe as one bubble in a cosmic foam, surrounded by countless others, each with its own laws of physics, its own story. Then, in Chapter 4, we ventured into the unknown beyond, asking whether it's a void of pure nothingness or something more, a higher dimensional realm, a cosmic scaffolding, or a reality we can't yet grasp. Now in Chapter 5, we're stepping back to ask the ultimate question: why does it all matter? Why do we, tiny specks on a pale blue dot, keep chasing these cosmic mysteries? What does our quest to understand what's beyond the universe tell us about who we are and where we're going? This is the final chapter, where science meets wonder, where questions become as important as answers, and where we find that the universe might be vast, but our curiosity is infinite. Picture yourself standing under a clear night sky, stars stretching out like a blanket of light. You feel small, don't you? But you also feel connected, like you're part of something immense. That feeling, that mix of awe and wonder, is what drives us to explore the cosmos. It's not just about finding answers, it's about asking the right questions. And the question of what lies beyond the universe is one of the biggest, most profound questions we can ask. It's not just about space or time or physics. It's about our place in the grand cosmic story, about why we exist at all, and whether we're alone in this vast, mysterious expanse. Let's start with a simple truth. Humans are curious, always have been. From the moment our ancestors looked up at the stars and wondered what those twinkling lights were, we've been asking big questions. Why is the sky blue? What makes the sun rise? Is there anything out there, beyond the edge of what we can see? That curiosity has driven us to build telescopes that peer billions of years into the past, to launch probes that sail past planets, to scribble equations that unravel the secrets of the cosmos. But when we ask what's beyond the universe, beyond the cosmic horizon, beyond the multiverse, beyond even the void, we're not just asking about stars or physics, we're asking about meaning. We're asking what it means to be human in a universe or a multiverse that's so much bigger than us. Let's rewind to where we started this journey. In Chapter 2, we learned about the cosmic horizon, the limit of what we can see, set by the speed of light and the universe's expansion. We imagined it as the edge of a cosmic ocean, a line where light fades and mystery begins. That horizon isn't just a physical boundary, it's a symbol of our limits, a reminder that no matter how far we look, there's always something more. In Chapter 3, we leaped into the multiverse, picturing our universe as one bubble in a foam of countless others, each with its own rules, its own reality. That idea stretched our imagination, suggesting that our universe might be just one note in a cosmic symphony. And in Chapter 4, we dared to ask what's beyond even the multiverse, whether it's a void, a higher dimensional bulk, or a reality so alien we can't describe it. Each chapter pushed us further, deeper, into the unknown, but it also brought us back to ourselves, to the spark of curiosity that makes us human. So, why do we care? Why do we spend billions of dollars building telescopes, launching satellites, and crunching numbers to understand something we might never see? The answer lies in that spark. Curiosity isn't just a trait, it's the engine of human progress. When our ancestors asked what the stars were, they didn't just sit there wondering. They told stories, built tools, and eventually discovered that those twinkling lights were suns, some with planets of their own. When we asked what's beyond the stars, we found galaxies. When we asked what's beyond galaxies, we found the cosmic web, filaments of matter stretching across billions of light years. And now, when we ask what's beyond the universe, we're not just looking for answers, we're continuing a tradition as old as humanity itself, a tradition of reaching for the unknown. Let's use an analogy to make this clearer. Imagine the universe as a giant, ancient book, and we're reading it page by page. Each page is a discovery, a new star, a new galaxy, a new law of physics. The cosmic horizon is the last page we can read right now, where the words start to blur and we can't make out what comes next. The multiverse is like discovering that our book is just one volume in a vast library, with countless other books, each telling a different story. And the void, or whatever lies beyond, is the space outside the library, the mystery that surrounds it all. Every time we turn a page, we learn something new, but we also find more questions. And that's the beauty of it. The questions keep us reading, keep us searching, keep us alive with wonder. Let's explore this idea of meaning with another analogy. Picture yourself as a sailor on a vast ocean, like we imagined in Chapter 2. Your ship is Earth, a tiny vessel in an endless sea of stars. You've got a map, the science we've built over centuries, but it only covers the waters you've sailed so far. The cosmic horizon is the edge of your map, where the chart fades into blank space. The multiverse is the idea that there are other oceans, other maps beyond your own, and the void, or something more, is the unknown that surrounds it all, the uncharted territory where no map exists. As a sailor, you could stay in safe waters, sticking to what you know, but something in you, a spark, a hunger, pushes you to sail toward the horizon, to explore the blank spaces, to find out what's out there. That's what it means to be human. We sail, we search, we dream. This drive to explore isn't just about finding answers, it's about finding ourselves. Every time we learn something new about the universe, we learn something about who we are. When we discovered that Earth orbits the Sun, we realized we weren't the center of everything. When we found galaxies beyond our own, we saw how small our corner of the cosmos is. And when we imagine a multiverse or a void beyond, we confront the possibility that our universe is just one piece of an infinite puzzle. Each discovery makes us feel smaller, but it also makes us feel bigger, because our minds can grasp these ideas, can dream of realities beyond our own. But this quest isn't just about science, it's about philosophy too. When we ask what's beyond the universe, we're really asking, what's the point? Why does the universe exist, and why are we here to wonder about it? These are questions that have echoed through history, from ancient philosophers staring at the heavens, to modern scientists peering through telescopes. Some say the universe exists because of a cosmic accident, a random burst of energy that sparked the Big Bang. Others believe it's part of a grand design, a purpose we can't yet see. The multiverse complicates things even more. If there are countless universes, each with its own rules, does that make our existence more random or more meaningful? Is our universe special because it supports life, or is it just one of many, a lucky roll of the cosmic dice? Take string theory, for example. In Chapter 3, we described it as a cosmic recipe book, where tiny vibrating strings create the particles and forces of our universe. String theory predicts there could be 10,500 possible universes, each with its own unique physics. That's a number so big it's almost meaningless. More universes than there are atoms in our observable universe. If string theory is right, then the void outside our universe might be a higher dimensional space where these other universes exist, each one a different recipe from the same cosmic cookbook. We can't prove it yet, but the math is compelling, like a clue to a mystery we're only beginning to solve. Or consider the work of cosmologists studying dark energy, the mysterious force driving the universe's expansion. In Chapter 2, we learn that the universe is stretching faster and faster, pulling galaxies apart and pushing the cosmic horizon farther away. Dark energy might hold clues to what's beyond, because it's tied to the very fabric of space itself. Some scientists think dark energy could be connected to the multiverse, a kind of cosmic glue that links our universe to others. Others wonder if it's a hint of the void outside, a force that shapes the boundaries of reality. Every experiment, every observation, brings us a step closer to understanding, even if the answers are still out of reach. Let's dive into the science for a moment, because it's the foundation of our quest. In Chapter 2, we talked about the cosmic microwave background, the faint glow left over from the Big Bang, like the echo of creation itself. Scientists study this glow to learn about the universe's early days, looking for clues about what came before and what might lie beyond. In Chapter 3, we explored how theories like eternal inflation suggest that our universe is one of many, each born from a burst of cosmic energy. And in Chapter 4, we imagined the void as a higher dimensional bulk or a quantum sea, buzzing with the potential for new realities. These ideas aren't just guesses. They're built on math, on observations, on the hard work of scientists who spend their lives chasing the ultimate question. This blend of science and philosophy is what makes the ultimate question so powerful. It's not just about what's out there, it's about why we care. Are we searching for answers to prove we're not alone? To find a purpose in the cosmos? To prove we can conquer the unknown? Every culture, every civilization has asked these questions in its own way. Ancient Greeks looked at the stars and saw gods. Medieval scholars saw a divine order. Today we see a universe governed by physics, but the wonder remains the same. We're still looking up, still asking, still dreaming. Let's reflect on what this means for us, here on Earth. Our planet is a tiny speck, a grain of sand in the cosmic ocean. Yet from this speck, we've built telescopes that see the edges of the universe, equations that predict the behavior of black holes, and stories that imagine other realities. That's extraordinary, isn't it? Our minds, so small in the grand scheme, can hold ideas as big as the multiverse. Our curiosity can reach beyond the cosmic horizon, beyond the void, to places we may never see. That's what makes this quest so special. It's not just about the universe, it's about us. But science can only take us so far. The ultimate question, what's beyond the universe and why does it matter, is as much about philosophy as it is about physics. Let's try another analogy to bridge the two. Imagine the universe as a painting, a vast canvas covered with stars, galaxies, and nebulae. Science is like studying the brushstrokes, figuring out how the paint was applied, what colors were used. Philosophy is about stepping back and asking, why was the painting made? Who's the artist? Is there a gallery full of other paintings, other universes, the void, or something more? Is the space beyond the canvas the mystery that surrounds the artwork? Science helps us analyze the painting. Philosophy helps us find meaning in it. What if we never find the answers? What if the void, or whatever lies beyond, remains a mystery forever? That's okay, because the search itself is meaningful. Every question we ask, every theory we test, every telescope we point at the sky is a step toward understanding. It's like climbing a mountain, not just to reach the top, but to see the view along the way. The ultimate question, what's beyond the universe, is a mountain we may never fully climb, but every step teaches us something new about the cosmos and about ourselves. For now, we don't have those answers. Our telescopes can't see past the cosmic horizon. Our equations can't yet map the void, but we have something just as powerful, our imagination. It's what lets us dream of bubble universes, higher dimensions, and cosmic symphonies. It's what lets us ask the ultimate question, even when the answer is out of reach. And it's what keeps us searching, building, exploring, generation after generation. Let's imagine for a moment what it would be like to know. What if we could peer beyond the void, see the structure of the multiverse, understand the cosmic scaffolding that holds it all together? Maybe we'd find a higher dimensional realm, alive with possibilities we can't imagine. Maybe we'd see other universes, each one a different story, a different dream. Or maybe we'd find true nothingness, a void so profound it defies description. Would that knowledge change us? Would it make us feel smaller? Or would it fill us with awe, knowing we're part of something so vast, so strange, so beautiful?